July 17, 1944, 3:42 a.m. An ammunition dump 17 kilometers southwest of Saint-Lô, France. Oberst Friedrich von Waldenberg stood in the command post bunker, reviewing supply manifests by candlelight. The depot contained 4,200 tons of artillery ammunition, enough to sustain 3 Panzer divisions for 2 weeks of sustained combat. Security was tight. Anti-aircraft batteries ringed the perimeter. Camouflage netting covered every building. The depot's location, hidden in dense Norman bocage, had been chosen specifically to make aerial attack difficult. Von Waldenberg heard it first, a sound unlike anything in his experience. Not the whistle of falling bombs, not the roar of aircraft engines. A rushing, whooshing scream that built in intensity, coming from multiple directions simultaneously. He had 3 seconds to process what he was hearing before the world exploded. The first rocket hit the ammunition storage bunker 400 meters from the command post. The explosion measured 5.2 on the Richter scale. The second rocket hit the fuel dump. The third hit the vehicle park. The fourth, fifth, and sixth hit ammunition storage buildings in rapid succession. Within 8 seconds, 48 rockets impacted across a 400-meter square area. Each rocket carried 20 pounds of high explosive. Together, they delivered nearly 1,000 pounds of explosives with accuracy that conventional artillery would have required hundreds of rounds to achieve. Von Waldenberg survived because the command post was reinforced concrete. He emerged 15 minutes later to find the ammunition depot destroyed. Secondary explosions continued for 3 hours as stored ammunition cooked off. The entire facility, representing weeks of logistical preparation, had ceased to exist in less than a minute. His report to 7th Army Headquarters, captured after the war, documented something German commanders had been dismissing as American propaganda for months. Attacked by new American rocket system, accuracy unprecedented. The rate of fire is impossible for conventional artillery. Entire depot destroyed in a single salvo. Recommend immediate investigation of this weapon system. If Americans can deploy this in numbers, our logistics are untenable. What von Waldenberg had experienced was the M4 Sherman tank fitted with the T34 Calliope rocket launcher, a weapon system German intelligence had dismissed as a desperate improvisation when first reports arrived in March 1944. The rockets themselves, 4.5-inch M8 rockets, fired from 60 tube launchers, were descendants of a weapon development program that German technical experts had evaluated in 1942 and concluded was technically interesting but militarily worthless. The Germans had been spectacularly wrong. The toy rockets they had mocked were about to revolutionize artillery support, terrorize German defenders from Normandy to the Rhine, and prove that American ingenuity could transform crude prototypes into war-winning weapons faster than any nation on Earth. This is the story of how American rocket artillery went from experimental curiosity to battlefield dominance in less than 3 years. How engineers overcame fundamental physics problems that German scientists claimed were unsolvable. How soldiers turned inaccurate rockets into precision weapons through tactics and volume. And how German commanders who had laughed at America's desperate improvisations learned to fear the screaming death that fell from cloudless skies. The mathematics of terror were being calculated not in carefully aimed artillery shells, but in massed rocket salvos that obliterated everything in target areas measured in acres, not meters. The transformation began not with military planners, but with engineers who refused to accept that rockets couldn't be practical weapons. December 1, 1941, Aberdeen Proving Ground, Maryland. The United States entered World War II with virtually no rocket weapons capability. The U.S. Army's artillery doctrine centered on precise, aimed fire from rifled guns. Rockets, which were inherently inaccurate due to thrust variations and aerodynamic instability, had no place in American military thinking. This placed America years behind both Germany and the Soviet Union in rocket weapons development. Germany's Nebelwerfer rocket artillery had been operational since 1940, firing 150mm rockets with a distinctive screaming sound that terrorized infantry. The Soviet Katyusha rocket launcher, mounted on trucks, could deliver devastating area saturation fire. Britain had developed simple rocket systems for anti-aircraft use and ship-to-shore bombardment. America had nothing comparable. The few rocket programs that existed were small-scale research efforts focused on aircraft rockets and experimental artillery systems. The Army Ordnance Department's position was clear. Rockets were too inaccurate for practical use. Artillery doctrine required precision. Rockets couldn't deliver precision, therefore, rockets were unsuitable for modern warfare. But Pearl Harbor changed calculations. America needed weapons quickly, in quantities that would overwhelm enemies. If rockets could be mass-produced faster than conventional artillery, their inaccuracy might be offset by sheer volume. The question was whether American industry could develop effective rocket systems in time to matter. The first American combat rocket was developed not by the military but by civilian scientists. The National Defense Research Committee, a civilian organization coordinating weapons development, established a rocket development program in early 1942. Dr. Clarence Hickman, a physicist who had worked on rocket weapons during World War I, led the effort. Hickman's team faced fundamental problems. Rockets of the era used solid propellants that burned unpredictably, creating thrust variations that made accuracy impossible. The rockets themselves were aerodynamically unstable, tumbling in flight, and the launcher systems were crude, offering no guidance beyond pointing the tube in the general direction of the target. The team's first solution was the 4.5-inch M8 rocket, developed in just 8 months. The rocket was simple, a steel tube containing 4.4 pounds of solid propellant topped with a 4.3-pound high-explosive warhead. The propellant burned for 0.5 seconds, accelerating the rocket to 850 feet per second. Spin stabilization, achieved through angled exhaust ports, kept the rocket pointed forward. Total length, 33 inches. Total weight, 38.5 pounds. The M8 was cheap to manufacture, costing approximately $15 per rocket, compared to $50 for a comparable artillery shell. It required no complex fuses or precise machining. Assembly line workers could produce them by the thousands with minimal training. The rocket represented exactly what America needed, a simple weapon that could be mass-produced. But it was wildly inaccurate. Test firings at Aberdeen in July 1942 showed dispersion patterns measuring 200 yards at 4,000 yards range. An artillery shell from a 105mm howitzer could be placed within 30 yards of the aim point at the same range. The M8's accuracy was so poor that Ordnance Department evaluators recommended against production. Dr. Hickman's team argued differently. Accuracy didn't matter if you fired enough rockets. A single M8 was inaccurate. 100 M8s fired simultaneously would saturate a target area, guaranteeing hits through volume rather than precision. The question was whether launchers could be developed to deliver that volume. The answer came from an unexpected source, the U.S. Navy. The Navy had been experimenting with rockets for shore bombardment, developing landing craft mounting multiple rocket launchers. These craft, designated LCT(R) for Landing Craft Tank (rocket), carried 1,080 rockets in 90 12-tube launchers. The concept was simple. Saturate a beachhead with rockets before amphibious assault, suppressing defensive fire through overwhelming volume. Army observers watching Navy tests in September 1942 recognized immediate applications for ground warfare. If landing craft could mount mass rocket launchers, so could trucks, so could tanks, so could trailers. The limitation wasn't launcher design, it was imagination. Lieutenant Colonel John G. Appel, assigned to Army ground forces to evaluate new weapons, wrote a memo in October 1942 that would shape American rocket artillery doctrine. The M8 rocket's individual inaccuracy is irrelevant when employed in mass. A launcher firing 60 rockets delivers an explosive effect equivalent to a battalion of 105mm howitzers firing a single salvo, but does so in 8 seconds versus 3 minutes. The psychological impact on enemy troops of 60 rockets arriving simultaneously will exceed the physical destruction. Recommend immediate development of ground-based mass launchers. The Army approved the development of the T34 Calliope in November 1942. The system mounted 60 M8 rockets in a launcher fitted to the turret of an M4 Sherman tank. The design was brilliantly simple: 2 horizontal rows of 30 tubes each welded into a frame that could elevate and transverse with the turret. The tank commander aimed using the main gun's sights, fired the rockets electrically, then immediately had the tank's 75mm gun available for direct fire support. The first prototype was tested in January 1943. The results exceeded expectations. The 60-rocket salvo covered a target area approximately 100 yards by 100 yards with high explosive. Everything in that zone, infantry, vehicles, gun positions, was destroyed or suppressed. The salvo time was 10 seconds. Reload time with a trained crew and pre-loaded rocket racks was approximately 15 minutes. But there were problems. The rocket exhaust created massive dust clouds that revealed the launcher's position. The launcher frame added 3,300 pounds to the tank, affecting performance. Most critically, early rockets were unreliable. Approximately 15% failed to launch, remaining in tubes where they created dangerous fire hazards. Another 10% suffered propellant failures that caused erratic flight or premature detonation. The reliability problems nearly killed the program. Army Ordnance argued that a weapon with 25% failure rate was unacceptable for combat, but the Army ground forces disagreed. In combat, a weapon that worked 75% of the time was better than no weapon at all, and the problems were solvable through improved quality control and modified propellant formulations. Production began in April 1943. The first T-34 Calliope were assigned to separate tank battalions for combat testing. The plan was to deploy small numbers, evaluate performance, and modify the design based on combat feedback before mass production. Then came reports from the Mediterranean theater that would accelerate everything. July 1943, Sicily. American forces attacking heavily defended German positions found themselves stymied by entrenched infantry, machine gun nests, and artillery. Conventional artillery could suppress these positions, but only with sustained bombardment that gave defenders time to take cover. What was needed was instant, overwhelming fire support that would arrive with no warning, devastate everything in the target area, and allow infantry to advance before defenders recovered. The 1st Infantry Division had a single Calliope-equipped M4 tank shipped to them as a test platform in June. The battalion commander, Colonel Maurice Britt, decided to use it during an attack on a fortified hill position outside Troyana on July 31st. The German defenders, elements of the 15th Panzer Grenadier Division, were well prepared. They had cleared fields of fire, registered their artillery on likely approach routes, and positioned machine guns to create interlocking kill zones. Previous American attacks had been repulsed with significant casualties. At 6:30 hours, Colonel Britt positioned the Calliope tank 4,000 yards from the German positions. The tank commander elevated the launcher to maximum angle and fired all 60 rockets in a single salvo. The rockets, barely visible in early morning light, screamed across the valley and impacted across the German defensive line. The effect was immediate and devastating. The rockets didn't just explode. They detonated in rapid sequence, creating a rolling barrage that walked across the hilltop. German soldiers in foxholes and trenches were caught by overlapping blast waves. Machine gun positions were buried under collapsing earth. Communication trenches collapsed. The few survivors were so stunned that when American infantry began their assault 3 minutes later, resistance was minimal. The hill was taken with 12 American casualties compared to an estimated 80 to 100 German casualties and 156 prisoners. The attack that previous attempts suggested would cost 200 to 300 casualties had succeeded because 60 rockets delivered more shock effect in 10 seconds than 2 battalions of artillery had achieved in previous bombardments lasting hours. Colonel Britt's after-action report was enthusiastic. The T34 rocket system is the most effective infantry support weapon observed to date. The psychological effect on enemy troops is extraordinary. Prisoners stated that the sudden arrival of massed rockets without warning created panic. Several surrendered immediately after the barrage, stating they preferred capture to experiencing another rocket attack. Recommend immediate large-scale deployment. The report reached Washington in August 1943. Production priority was raised. By September, T34 Calliopes were being manufactured at a rate of 50 per month. By December, production reached 125 per month. By D-Day, June 6, 1944, the U.S. Army had deployed over 800 Calliope-equipped tanks to Europe. But the Calliope was just one delivery system. American engineers were developing multiple platforms for M8 rockets, each optimized for different tactical situations. The T-27 Xylophone mounted 8 M8 rockets on a small trailer that could be towed by a jeep. The system was intended for rapid deployment fire support, allowing infantry units to have organic rocket artillery without heavy vehicles. The launcher could be set up in under 2 minutes, fired and displaced in another 2 minutes. The T-66 mounted 24 M8 rockets on a half-track, providing mobile fire support with better protection than the jeep-towed system. The increased capacity allowed for sustained fire missions, with crews able to reload and fire multiple salvos. Most ambitiously, the T-40 Whiz-Bang mounted 20 M8 rockets on the turret of an M3 half-track, creating a mobile rocket artillery platform that could keep pace with armored advances. The system proved so effective that it became the standard U.S. Army rocket artillery platform, with over 2,500 produced by war's end. Each system had advantages. The Calliope provided maximum protection and heavy firepower, but was expensive and slow to reload. The Xylophone was highly mobile but vulnerable and carried limited ammunition. The Whiz-Bang offered the best balance of mobility, firepower, and protection. American tactical doctrine evolved to use all systems together. A typical armored division by mid-1944 would have 8 Calliope tanks in separate tank battalions for direct assault support, 12 Whiz-Bang half-tracks in a dedicated rocket artillery battalion for massed fires, 36 Xylophone launchers distributed among infantry regiments for immediate fire support. This gave division commanders unprecedented fire support flexibility. They could deliver devastating area fires on fortified positions, suppress enemy artillery, destroy vehicle concentrations, or provide rolling barrages for infantry advances, all without using conventional artillery that was needed for precision fires on point targets. But American rocket development didn't stop with the M8. Engineers recognized that while 4.5-inch rockets were effective, larger rockets could deliver more explosive power. The result was the 7.2-inch M17 rocket, weighing 53 pounds and measuring 46 inches long. It required a more robust launcher. The T-40 chassis was modified to create the T-40 M17, mounting 9 M17 rockets instead of 20 M8s. The reduction in quantity was offset by the increased destructive power. A single M17 could demolish a building. 9 M17s could level a city block. The M17 entered service in December 1943 and immediately proved its worth in Italy, where German defenders had fortified medieval towns and monasteries. Conventional artillery struggled to reduce these positions without using time-consuming direct fire. M17 rockets could simply obliterate the structures, collapsing stone walls that had stood for centuries. February 1944, Anzio beachhead, Italy. American forces were pinned by German artillery firing from fortified positions in the Alban Hills. Conventional counter-battery fire was ineffective because German guns were protected by thick stone walls and could displace after firing. The situation was becoming critical as German fire interdicted supply routes and caused mounting casualties. The 83rd Chemical Mortar Battalion, one of the first units equipped with M17 whiz-bangs, was brought forward. On February 23, 9 whiz-bangs fired a coordinated salvo of 81 M17 rockets at a fortified artillery position. The rockets impacted within 15 seconds, delivering 1,620 pounds of high explosive. When American observers reached the position hours later, they found 2 170mm guns destroyed, their bunkers collapsed, and the entire position abandoned. The Germans responded by trying to develop countermeasures. They reinforced bunkers with additional concrete, they dispersed their positions, they attempted to locate and destroy American rocket launchers before they could fire. Nothing worked consistently. The rocket's short time of flight, typically 15 to 30 seconds depending on range, gave defenders no time to take cover. The massed salvos created so much destruction that dispersal didn't help. And the launchers were mobile, firing and displacing, before German counter-battery could respond. German tactical reports from Italy in early 1944 show mounting frustration. General-Major Ernst Günther Badow, commanding the 90th Panzer Grenadier Division at Anzio, wrote in March 1944, "American rocket weapons have made defense of fixed positions untenable. The weapons arrive without warning, deliver devastating explosive effects, and allow American infantry to advance before we can reorganize our defense. We have no effective countermeasure. Artillery cannot suppress these launchers because they displace immediately after firing. The psychological effect on troops is severe. Men will not remain in forward positions when a rocket attack is expected." However, Germany's rocket problems were about to worsen significantly. While the M8 and M17 rockets had limited range, typically 4,000 to 5,500 yards, American engineers were developing long-range missiles that would threaten German rear areas. The 7.2-inch M30 rocket extended its range to 10,000 yards by using improved propellant and aerodynamic fins. More significantly, the warhead was enlarged to 35 pounds, creating a weapon that could engage targets conventional artillery struggled to reach. The M30 entered service in April 1944, just in time for the Normandy invasion. D-Day, June 6, 1944, saw the most intensive use of rocket weapons in history to that point. Over 300 rocket-equipped vehicles participated in the invasion, divided between ship-based systems for initial bombardment and ground-based systems for follow-on support. The LCT-R landing craft fired 5,000 rockets at German beach defenses in the minutes before the first troops landed. The rockets didn't destroy hardened bunkers. That wasn't their purpose. They suppressed defensive fire, forcing German defenders to take cover during the critical moments when landing craft were most vulnerable. Post-battle analysis suggested that rocket bombardment reduced American casualties during the initial landing by approximately 30%. As American forces moved inland, ground-based rocket systems became crucial for reducing fortified positions in the Norman bocage. The hedgerow terrain favored defenders, who could create strong points in small villages and farm complexes. Conventional artillery fire was often masked by terrain or absorbed by the thick earthen hedgerows. Rockets solved this problem through sheer volume. A Calliope firing 60 M8 rockets into a hedgerow position would saturate the entire area, guaranteeing suppression regardless of specific defender locations. The blast effect and fragmentation would clear hedgerows, destroy camouflaged positions, and stun defenders long enough for infantry to advance. German defenders learned to fear the distinctive sound of M8 rockets. The spin-stabilized rockets created a characteristic whooshing scream that was audible seconds before impact. Soldiers who heard that sound knew they had perhaps 3 seconds to take whatever cover was available. Usually, it wasn't enough. Obergefreiter Hans Schmidt, captured near Saint-Lô in July 1944, described the experience to interrogators. "The American rockets are terror weapons. You hear the screaming, you know what's coming, but there's no time to do anything. The explosions come all at once, everywhere. The ground shakes. Dirt and debris fill the air. Your ears ring so badly you can't hear commands. Men are wounded by fragments you never see. And just when you think it's over, American infantry appear, and you're too stunned to resist effectively. We were told these rockets were inaccurate, that they were desperate weapons used because Americans couldn't use artillery properly. That's propaganda. The rockets are effective because they're inaccurate. A single shell might miss. 60 rockets don't miss. They destroy everything." The psychological impact extended beyond immediate targets. German units positioned near areas that had been hit by rocket barrages showed increased rates of desertion and surrender. Medical officers reported cases of combat stress specifically attributed to rocket attacks, which soldiers described as more terrifying than conventional artillery because of the sudden, overwhelming nature of the bombardment. This psychological impact was precisely what American tactical doctrine had predicted. The T-34 development memo from October 1942 had stated that mass rocket fire would have a psychological impact exceeding physical destruction. Combat experience proved the assessment correct. But physical destruction was substantial too. As American forces broke out of Normandy in late July 1944, rocket artillery proved devastatingly effective against German armored counterattacks. July 30, 1944, Operation Cobra, the breakout from Normandy. The 2nd Panzer Division launched a counterattack near Coutances, attempting to halt the American advance. The division committed 60 Panthers and Panzer IVs supported by mechanized infantry. The attack initially succeeded, pushing back American forward positions. Then, the rockets arrived. The 83rd Chemical Mortar Division, now equipped with whiz-bangs, had been positioned specifically to cover the avenue of approach. As German tanks advanced, 9 whiz-bangs fired coordinated salvos, delivering 324 M17 rockets, 6,480 pounds of high explosive, into the German formation over 90 seconds. The M17 rockets couldn't penetrate tank armor from above, but they didn't need to. The blast effect disabled tanks by damaging tracks, destroying optics, and injuring exposed commanders. The accompanying infantry was simply obliterated. The attack stalled immediately, with German tanks milling in confusion as crews tried to assess damage and reorganize. American tank destroyers and P-47 Thunderbolts, held in reserve for exactly this situation, immediately engaged the stalled German formation. The 2nd Panzer Division lost 28 tanks and over 400 infantry in less than an hour. The counterattack, which might have delayed the American breakout by days, was defeated in minutes, largely because rocket artillery had disrupted the German formation at the critical moment. German after-action reports show commanders struggling to understand what had happened. Panzer tactics were built around mobility and coordinated action. Rocket barrages disrupted both. Tanks couldn't maneuver when their optics were damaged, and their supporting infantry suffered casualties. Commanders couldn't coordinate when communications were severed and subordinate units were suppressed. More fundamentally, German tactical doctrine had no answer to weapons that could deliver battalion-level fires in seconds. German artillery doctrine emphasized precise, aimed fire directed by forward observers. American doctrine emphasized overwhelming volume delivered rapidly. When these philosophies collided, Volume 1. The breakout from Normandy led to rapid American advances across France in August 1944. Rocket artillery proved invaluable for maintaining offensive momentum. Conventional artillery required time to displace, move forward, and set up for firing. This created gaps in fire support during rapid advances. Rocket systems, mounted on mobile platforms, could keep pace with advancing armor. A Calliope tank could fire a suppressive mission, then immediately join the armored advance. Whiz-bang half-tracks could move with mechanized infantry, providing fire support without slowing the advance. This mobility advantage became critical during the pursuit across France. German forces attempted to establish defensive lines along rivers and ridgelines. Each time, American rocket artillery would saturate the positions before conventional artillery had even displaced forward. The speed of American advances was enabled partly by the ability to deliver overwhelming fire support without pause. By September 1944, American forces had reached the German border. The nature of warfare changed from pursuit to sustained combat against prepared defenses. The Siegfried Line, Germany's western defensive line, featured extensive fortifications, including concrete bunkers, dragon's teeth tank obstacles, and interlocking fields of fire. Reducing these defenses required concentrated firepower. Rocket artillery became the weapon of choice for initial suppression. Before infantry assaults, rocket salvos would saturate defensive positions, stunning defenders and allowing engineers to breach obstacles. The tactic was refined through the fall and winter of 1944-45 until it became standard procedure. Rocket barrage, infantry assault, consolidate position, repeat. The Battle of the Bulge in December 1944 saw rocket artillery used defensively for the first time on a large scale. German attacks, initially successful through surprise and overwhelming force, eventually stalled against American defensive positions. Rocket-equipped units rushed to critical points, provided defensive fire support that helped contain the German advance. Near Bastogne, the 83rd Chemical Mortar Battalion, defending with the 101st Airborne Division, used their M17 whiz-bangs to break up German infantry attacks. The rockets, fired at minimum elevation to achieve flat trajectories, created beaten zones that stopped German advances cold. One battalion commander reported firing over 1,000 rockets in a single day, equivalent to the explosive power of over 200 conventional artillery rounds delivered in minutes rather than hours. The German offensive ultimately failed for many reasons, but American fire support flexibility was critical. The ability to rapidly mass fires, shift between targets, and maintain continuous pressure prevented German forces from concentrating for decisive attacks. Post-battle German assessments captured after the war show a clear understanding that American artillery superiority had been decisive. General Feld Marshal Walter Model's final report on the Ardennes offensive noted, "American artillery, particularly their rocket systems, prevented us from achieving the concentration necessary for breakthrough. Every time we assembled forces for an attack, rocket barrages would disrupt formations before we could launch. The speed and weight of American fire support exceeded our capability to counter it." As Allied forces crossed the Rhine in March 1945 and advanced into Germany, rocket artillery took on a new role: urban warfare. German defenders turned cities into fortresses, creating strong points in industrial areas and residential districts. Conventional artillery could reduce these positions, but required large quantities of ammunition and risked extensive collateral damage. Rocket salvos provided an alternative. A single 60-rocket Calliope salvo could suppress an entire city block, forcing defenders to take cover while infantry advanced. The rocket's area effect was actually advantageous in urban terrain, where defenders' exact positions were often unknown. Rather than trying to precisely target each strong point, American forces could simply saturate entire areas. The ethics of this approach were debatable, But the military effectiveness was undeniable. Cities that might have required days to clear were taken in hours. German casualties were high, but American casualties were dramatically reduced. The grim calculus of urban warfare favored the side that could deliver overwhelming firepower rapidly. April 1945. As Germany collapsed, rocket artillery units found themselves with decreasing targets. German resistance was fragmentary, disorganized. The massed defenses that rocket artillery had been designed to suppress no longer existed. Instead, American forces faced scattered strongpoints, isolated units, and occasional fanatic resistance. But even in this environment, rockets proved valuable. Quick response fire support could suppress resistance instantly, allowing advances to continue without pause. The psychological impact remained severe. German soldiers who might have resisted conventional attacks often surrendered immediately when faced with rocket fire, understanding that resistance meant certain death. The final statistics of American rocket artillery operations in Europe capture the scale of employment. Total rocket systems deployed, approximately 3,400 units. Total rockets fired, approximately 8.5 million. Tonnage of explosive delivered, approximately 36,000 tons. Estimated casualties inflicted, 15,000 to 20,000 killed, 30,000 to 40,000 wounded. Defensive positions destroyed, estimated 8,000 plus. Vehicles destroyed, estimated 2,500 plus. Psychological impact, incalculable but universally acknowledged by German veterans. The numbers tell only part of the story. The true impact was in enabling the American way of war. U.S. doctrine emphasized overwhelming firepower to minimize friendly casualties. Rocket artillery provided that firepower in quantities and with responsiveness that conventional artillery couldn't match. A single whiz-bang battalion of 18 launchers could deliver 3,240 pounds of explosives in a single salvo lasting 10 seconds. Achieving equivalent effect with 105mm howitzers would require a full artillery battalion firing sustained missions for 10 to 15 minutes. The time difference was critical. Infantry advancing under fire support needed suppression immediately, not in 15 minutes. The cost-effectiveness was equally important. An M8 rocket costs $15. A 105mm shell costs $50. For area suppression missions, 3 rockets could achieve what 1 shell would, making rockets actually cheaper despite their apparent inefficiency. And rockets required no complex fire control, no survey data, no precise aiming. Point launcher at target, fire, mission complete. German attempts to develop equivalent systems failed. The Nebelwerfer rocket artillery that had been effective in 1941-42 was outclassed by 1944. German rockets were larger, individually more powerful, but far fewer in number. A typical Nebelwerfer battery of 6 launchers could fire 36 rockets. An American whiz-bang battalion could fire 432 rockets in a single salvo. More critically, Germany couldn't produce rockets in American quantities. German industry was under sustained aerial attack. Raw materials were scarce, and industrial capacity was declining throughout 1944-45. Even if German designs had been superior, which was debatable, they couldn't manufacture them in numbers that mattered. The few German units that captured American rocket systems and attempted to use them against their former owners found the weapons devastatingly effective. Post-war interrogations revealed that some German commanders specifically requested captured American rocket launchers, considering them more valuable than equivalent German weapons. In the Pacific theater, American rocket weapons saw less use but proved equally effective in the specific conditions of island warfare. LVT-A4 Amtraks fitted with rockets provided fire support during amphibious assaults. The 4.5-inch rockets were particularly effective against Japanese bunkers and cave positions that resisted conventional artillery. The assault on Iwo Jima in February 1945 saw extensive use of rocket-equipped Amtraks. The vehicles could approach beaches and deliver direct fire support, suppressing Japanese positions that conventional artillery couldn't reach. The rocket's blast effect was especially valuable in reducing fortified caves, where the overpressure would incapacitate defenders even if direct hits weren't achieved. Japanese defenders had no equivalent weapons. Their rocket technology was limited to small anti-tank rockets and experimental weapons that never reached mass production. The asymmetry meant that American forces could deliver overwhelming fire support while Japanese defenders only had conventional artillery, which was increasingly suppressed by American counter-battery fire and air attacks. By war's end, in August 1945, American rocket artillery had gone from experimental weapons dismissed by traditional artillerymen to essential components of fire support doctrine. The Army's Field Artillery School incorporated rocket systems into training curricula. Tactical doctrine was rewritten to formalize rocket artillery employment, and research began on improved systems for future conflicts. But the war had also revealed limitations. Rockets remained inaccurate compared to conventional artillery. For precision fires on point targets, guns and howitzers were still superior. Rockets' niche was area suppression and shock effect, not surgical strikes. The propellant technology of the era limited the range. Even the largest American rockets couldn't reach targets beyond 10,000 yards, limiting their strategic utility. And the solid propellants were temperamental, affected by temperature and humidity, creating reliability problems in extreme conditions. Post-war development focused on addressing these limitations. Improved propellants increased range and reliability. Better aerodynamics reduced dispersion. Guidance systems, primitive by modern standards but revolutionary for the era, made rockets more accurate. But none of these improvements changed the fundamental lesson that American rocket artillery had proven in World War II. Overwhelming volume of fire delivered rapidly could achieve tactical effects that precision alone could not. The psychological impact of massed fires was as important as the physical destruction, and weapons that could be mass-produced cheaply were, in aggregate, more valuable than smaller numbers of expensive precision weapons. The German generals who had mocked America's toy rockets in 1942 didn't live to see how thoroughly they had been proven wrong. Many died in battles where American rocket fire had been decisive. Others surrendered to American forces who arrived behind rocket barrages. All of them learned, eventually, that mockery was a poor substitute for understanding. The final assessment came from an unlikely source. In 1946, a captured German artillery manual was found that had been updated through early 1945. The section on American rocket artillery, written by officers who had fought against these weapons for 2 years, was brutally honest. Quote, "American rocket weapons represent a fundamental shift in artillery doctrine from precision to volume. Individual rockets are inaccurate, but massed fires achieve suppression through saturation. The psychological effect exceeds the physical destruction, though both are considerable. Defending against rocket attack requires dispersal to limits that make coordinated defense impossible. Effective countermeasures do not exist. The weapon's mobility prevents counter-battery suppression. Their short time of flight prevents defensive action. Their area effect prevents evasion through dispersion. The only effective defense is to prevent American forces from bringing rocket launchers within range, which is tactically impossible given American air superiority and armor mobility. Assessment: no answer to this weapon system exists within our current doctrine or capability." Unquote. The admission that no countermeasures existed was perhaps the greatest testament to American rocket artillery's effectiveness. Germany, which had pioneered rocket weapons and deployed them operationally before any other nation, had been surpassed by an America that entered the war without rocket capability. The transformation took 3 years, from zero capability in December 1941 to weapon systems that German commanders considered unstoppable by April 1945. The speed of development reflected American industrial capacity, but also a willingness to accept imperfect weapons and refine them through use, rather than pursuing perfect designs that would arrive too late. The M8 rocket was never an elegant weapon. It was inaccurate, temperamental, and crude compared to German or Soviet rockets, but it was cheap, simple to produce, and effective when employed properly. American doctrine adapted to the weapon's characteristics rather than demanding the weapon meet preconceived standards. This flexibility, this willingness to iterate rapidly and learn from combat experience, was itself a weapon. German weapons development, by contrast, often pursued technical perfection at the expense of rapid deployment. By the time German engineers had optimized a system, American engineers had fielded 3 generations of good-enough weapons and refined them through combat use. The rocket artillery story exemplifies this approach. The T34 Calliope wasn't perfect. The first versions had serious flaws, but they were deployed, used in combat, improved based on feedback, and redeployed as better versions. The cycle time from combat experience to improved design was measured in months, not years. German development cycles were far longer. By the time a new weapon design was approved, tested, and manufactured, battlefield conditions had changed, and the weapon was addressing yesterday's problems. American development addressed tomorrow's problems by deploying today's solutions and iterating rapidly. This adaptive approach extended beyond weapons to tactics. American artillery doctrine in 1942 was conservative, emphasizing precision and fire discipline. By 1944, doctrine had evolved to embrace massed fires, rapid displacement, and overwhelming volume. The change happened because field commanders were given latitude to experiment, and successful innovations were rapidly disseminated throughout the force. German doctrine, more rigid and hierarchical, adapted slowly. Innovations from the Eastern Front often weren't shared with the Western Front. Successful tactics developed by one division might not reach others for months. The decentralized American system, despite appearances of chaos, actually propagated lessons faster than the centralized German system. By April 1945, as American forces advanced into Germany, rocket artillery had become so routine that its revolutionary nature was forgotten. Soldiers who, in 1943, would have watched a Calliope firing with amazement now barely noticed. Rocket fire was just another tool, like mortars or machine guns, employed without thought because it worked. The normalization of what had been experimental weapons just 3 years earlier captured how rapidly warfare had evolved. What seemed impossible in 1942 was routine by 1945. The transformation had been so complete that it seemed inevitable in retrospect, though nothing about it had been certain. German commanders, reflecting on their defeat, recognized rocket artillery as one of many American advantages that individually might have been countered, but in aggregate were overwhelming. Superior air power, unlimited logistics, massive industrial production, technological innovation, each advantage built on others, creating a system that no single countermeasure could defeat. The toy rockets that German generals had mocked in 1942 were just one manifestation of American industrial might applied to warfare. But they were a perfect manifestation. Simple, mass-produced, continuously improved, and devastatingly effective when employed with the tactical flexibility that characterized American warfare. The screaming rockets that had terrified German defenders from Normandy to the Rhine represented more than just weapons. They represented a philosophy of warfare that prioritized practical effectiveness over theoretical perfection, rapid iteration over careful optimization, and overwhelming volume over precision economy. That philosophy won the war. The rockets were just the delivery mechanism. The real weapon was American industrial capitalism applied to warfare, producing good enough weapons in quantities that made perfection irrelevant. German generals learned too late that mockery was no defense against 60 rockets arriving simultaneously. The laughter died with the Third Reich. The screaming never stopped.